Rocketdyne places a great deal of importance on its good neighbor practices and adherence to the Rockwell Credo, which states an obligation to the communities in which its employees live and work. Rocketdyne is the largest employer in the West San Fernando Valley, employing over 6,500 people. These employees take great pride while at work to ensure the safety of their communities. The purpose of this video is to familiarize the community with Building 886, the former sodium disposal facility at the Santa Susana Field Laboratory. A massive cleanup is currently underway. We'll show you what has already been accomplished and discuss what lies ahead for the future. Rocketdyne's cleanup effort places priorities on the health and safety of the employees and surrounding communities, protection of the environment, and compliance with regulatory requirements and objectives. The U.S. Department of Energy, or DOE, San Francisco Operations Office, performs in an oversight capacity and has accepted the financial responsibility for this project. Other regulatory agencies overseeing this effort include the California Regional Water Quality Control Board, or Water Board, the California Environmental Protection Agency Department of Toxic Substances Control, and the County of Ventura Department of Building and Safety, to name a few.
We're here today to verify progress on the excavation and removal of contaminated soil from the sodium burn pit. We're very pleased with the progress that's being made here. Everything that was put into the cleanup and abatement order regarding the excavation of this sodium burn pit is being complied with at this time.
The former sodium disposal facility is located at the westernmost extreme of the Santa Susana complex. It is a triangular area containing an upper pond, lower pond, and western region. The soils are approximately 6 feet deep on the average over the entire 2-acre site, of which less than 10% is suspected to be contaminated. The facility was used as a disposal site in the late 50s through the mid-70s, a time when environmental regulations were less restrictive than they are today. In the mid-70s, other more efficient and controlled methods of disposal were found, and the Area 886 sodium disposal facility was no longer used. The contaminants at the site are varied, falling into the general categories of organics, solvents and their decay products, inorganics, heavy metals, and miscellaneous substances, including PCBs, petroleum hydrocarbons, and greases. Although disposal of radioactive material has always been prohibited at Santa Susana Field Laboratory, a small amount of low-level radioactive material was inadvertently disposed of at this facility. During the 70s and 80s, when Rocketdyne funds were available, several limited cleanup actions were taken, mainly removing surface debris. In 1984, traces of TCE, an industrial solvent, were found in water wells at Santa Susana. Extensive soil samples were taken, and test wells were installed near the site. An investigation was conducted in 1986 to identify materials that may have been disposed of there. Then, in 1989, Area 886 was added to the DOE's 5-year plan for environmental cleanup. In 1991, the Water Board examined the site and then issued a closure order to remove all contamination from the lower pond on or before December 31, 1992. Although the closure order specifies the lower pond, Rocketdyne's plan for remediation of the site is more comprehensive. This includes removal of all contaminated soils, focusing on the lower pond first, in order to meet the December deadline. All objects beneath the surface will be excavated and all structures demolished. The actual cleanup process began in February of '92. Using a coordinate grid system laid out over the entire site, a radiation survey was performed. The maximum amount of radiation detected at the surface is consistent with surface surveys taken in prior years and is less than 1/10 of the exposure rate of air travel. Also using the grid system, a geophysical survey was conducted. By measuring the magnetic fields of the soil, the location of metallic objects below the surface were indicated. A powerful ground-penetrating radar was then used in the indicated areas, and from this, a map was drawn showing the spatial location of the underground objects. Approximately 90% of the objects identified on the geophysical map have been excavated. Rocketdyne is taking great care to comply with all regulatory agency rules and regulations. The company has obtained all required permits, and all cleanup personnel have been trained in health and safety policies, OSHA regulations, and have had at least 60 hours of classroom training for work at this specific site. Actual excavation wasn't able to begin until early March of '92. Wet soils from the very heavy spring rains precluded the use of powered machinery, and continuing rains prevented productive work. Excavation was intermittent until mid-April, when natural drying allowed for use of motorized equipment. In May, under the instruction of the DOE, all excavations in the suspected mixed waste regions came to a halt. Because there was no known site for disposal or treatment of mixed wastes, a combination of radioactive and chemical soils, Rocketdyne would be in violation of federal law if generating such wastes. Rocketdyne was able to locate a chemical lab in South Carolina that proved such wastes could be treated for disposal, and full excavations were finally resumed in September of this year.
Well, simply stated, we believe that we have identified a source of contamination for groundwater in this vicinity, and with the completion of the sodium burn pit soil removal, we will have eliminated one of the possible sources of this groundwater contamination. And we feel good about the fact that we've done that, and I think the community should as well.
Each plot of soil excavated goes through a meticulous process. First, the soil is dug up with a backhoe and emptied into a container which is equipped with a hollow tube down the center. Next, a radioactivity detection device is inserted into the hollow tube and a measurement is taken. If the soil is determined to be radioactive, it is put into a large yellow storage bin and labeled radioactive. If the soil is determined non-radioactive, the container is emptied into the sorting machine. The coarse grill work at the top of the sorting machine allows for the removal of large objects which may not have been detected in the excavation, such as wood, roots, or plastic. The soil is then conveyed to other screens where they are separated further. The final product is of two types. One is a fine soil, and the other a coarser soil that is spot-checked for additional small objects which are removed. When a sufficient quantity of radioactive soils have been accumulated, they too will be run through the sorter for removal of small objects. The non-radioactive soils are put into large bins of various colors which have no significance. When completely filled, several samples are taken from each storage bin and are sent to a chemistry laboratory. It is necessary to determine the chemical composition and concentration of the contaminants in the soils to assure that they will be sent to the proper disposal site. The sampling procedure is rigorously followed to assure that reliable results will be obtained. Special samples of known contaminants are sent without the laboratory's knowledge for a double check. There are several safety features and precautions taken on the site. Each worker going into a contaminated zone is required to wear full protective gear. When they leave that area, they must decontaminate, leaving all exposed gear in the decontamination area. They are then checked for chemical and radioactive contamination. The air is also monitored to determine if respiratory protection is needed. Dust control is an important issue. Soil on the site is constantly being sprayed with water to prevent dust from flying away from the site. Because the December deadline demands accelerated efforts, the work is done in 2 shifts, starting early in the morning and on into the night. The main objective is to remove the contamination from the lower pond before the rainfall begins. When excavation has been completed, the exposed surfaces will be examined by state and federal regulators for any remaining contaminants. Upon approvals of cleanliness, restoration of the site will begin. This involves backfilling the excavated areas with clean soils brought to the site. The area will be graded to conform to the natural contours for drainage control and revegetated to native species. A cluster well, made up of 3 holes to different depths, will be located at the site, which will provide information about the subterranean soils and water-bearing bedrock structures. This information will be used to explain the movement of groundwater and further characterize contamination at the site. A second well will be installed near the site for extraction purposes. It will pump water to the surface, which can be sampled on a continuous basis and enables treatment of the groundwater if it is found to be contaminated. Finally, the site will be included into the area-wide Santa Susana Environmental Monitoring Program. These ongoing examinations will confirm freedom from soil migration and erosion, maintenance of vegetation, and the condition of groundwaters.
In this particular case, we had some overlapping federal and state regulations that has caused some delay in getting those resolved. In addition to that, we had some significant rains here. But notwithstanding those points, we believe that the progress has been good here, and it's typical of what you find in the investigation and cleanup arena today.
Rocketdyne has every intention of meeting the Water Board's December deadline. However, in the event of rain, Rocketdyne is required by regulators to cover the excavation area and collect and dispose of surface waters. In addition, wet soils cannot be properly excavated and segregated, making the deadline a challenging one in the face of potential rains. There are ecological issues recognized by Rocketdyne, the DOE, and the community. Live oak trees must be protected from damage. Selected foliage such as tarweed is protected, and transitory waterways are controlled. This cleanup is an example of a partnership between the DOE and Rocketdyne, and is only one of several remedial actions identified in the DOE's Environmental Restoration Program. Rocketdyne is working day and night to comply with the closure order. Rocketdyne and the DOE are equally dedicated to returning Area 886, the former sodium disposal facility, to an environmentally acceptable condition, an achievement which is in the best interests of all concerned.